In this problem, we're given a displacement time graph to analyze. This graph represents an elevator moving up and down an elevator shaft. At 0 seconds, it's at the ground level at 0. It goes up until it gets to 20 meters. It stays at 20 meters for a second. It comes back down to ground level, then goes into the basement, -5 meters or 5 meters below the ground level, and then stays there. Let's remember, for a displacement time graph, if we take the slope, we get the velocity. One way I have my students memorize that is to write the word diva vertically. From a distance time graph, you can get velocity, or from velocity time graph, you can get acceleration by taking the slope. But if you have a velocity time graph and you want distance, you should be taking the area. So I tell them, remember that if you can ski down slope, but you can't ski up slope. So if you write it vertically, you can go from distance time graphs to get velocity, or velocity time graphs to acceleration by taking the slope. And if you have a velocity time graph and you want distance or displacement, you have to take the area. Alright, our first question. During what time interval was the elevator at rest? Meaning it was not moving or changing its position. That occurred from 4 to 5 seconds and from 8 to 10 seconds. So for A, 4 to 5 and 8 to 10 seconds. Question B. During what time interval was the elevator moving at constant velocity? So remember, that means that the slope was not changing. It means we had a straight line. So there was those two spots, from 2 to 4 seconds and from 5 to 6 seconds. During what interval was the elevator accelerating? On a distance time graph or a displacement time graph or a position time graph, a curve will show an acceleration because the slope is constantly changing on a curve, and so the velocity is changing. So we have a curve from 0 to 2 seconds and a curve from 6 to 8 seconds. Letter D, during what time interval was the elevator moving upward? Well, it moved up from 0 seconds until 4 seconds, where it stopped. Letter E, during what time interval was the elevator moving downward? From 5 seconds until 8 seconds, it was moving down. From 0 to 2 seconds, was the elevator speeding up or slowing down? So we're looking at this segment here. If I look at the slope here, it's not quite as steep as later on in that curve. The slope of the curve increases. So you can see the tangent of this slope increases, and so it must have been speeding up. In letter G, however, you can see the tangent line becomes less steep. It's a big negative number, and then it approaches 0. So here it must be slowing down. Letter H. What was the elevator's displacement for the first 4 seconds? Well, it started at 0, and by 4 seconds it was at 20, so its displacement is just 20 meters, and it's in the positive direction. Remember, displacement has direction, so I'm going to say up. How far did the elevator travel in the first 4 seconds? That's just asking for distance. So there we can just say 20 meters. It's a scalar. What was the elevator's displacement for the first 6 seconds? Well, at 6 seconds it made it still up to, 6 seconds, it was back to here. So its displacement from 0 to 0 is just 0 meters. But the distance it traveled, it went up 20 meters and went back down 20 meters, and so we get 40 meters. What was the displacement after 8 seconds? So it started at 0 and it went down 5 meters. How far did it travel in the first 8 seconds? It had gone up 20, back 20, that's 40, and down an additional 5, that's 45 meters. Calculate the average velocity of the train for the seconds, 2 seconds to 4 seconds. So find the average velocity from here to here. Remember, this is a distance or a displacement time graph. We want velocity, we'll take the slope. So I'll write my equation, change in y over change in x. My y over here is 20 meters, and over here is 10 meters. My x is 4 seconds, and my x is 2 seconds. So I end up with 10 meters over 2 seconds, which is 5 meters per second. Calculate the average velocity for the first 4 seconds. So now we're going from here to here. Let me do that in a different color so we don't get confused. From here to here. Now we have this curve to deal with. But if we're looking for average velocity, we can just connect these two dots with an imaginary line and find the slope of that imaginary line. So change in y over change in x. This time we go from 20 meters up here to 0 meters, and 4 seconds and 0 seconds. We get 20 meters over 4 seconds, which is also 5 meters per second. It happens to have the same average velocity as before, but that does not have to be the case. Calculate the average speed of the train for the first 6 seconds. So in the first 6 seconds, it went out 20 and back 20. So the total distance it traveled was 40 meters. Speed is distance over time. 40 meters over 6 seconds is 6.7 meters per second. But for letter Q, they don't ask about average speed, they ask for average velocity, which is displacement over time. Notice that from 0 to 6 seconds, the displacement was 0, and so the velocity is 0 meters per second on average.